On example 5 in your notes, it says, one brand of baby bathtub comes with a dial to set the water temperature. When the baby safe setting is selected and the tub is filled, the temperature X of the water is randomly selected bath follows a normal distribution with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. Y is the temperature of the water in degrees Fahrenheit for the randomly selected bath. And there's the formula there for converting Fahrenheit or Celsius into Fahrenheit. And first I just want to know these two random variables of X and Y, the distribution in Celsius and the distribution in Fahrenheit. I want to know about how they compare. Now remember we said no matter what transformation you perform, as long as it's a linear transformation with just addition, subtraction, multiplication, and division, the shapes will not change. So for this first part, the shapes are identical. They are both identical. I can spell while I talk. They are both normally distributed. If one's normally distributed, so will the other one. And then I want the mean of Y. So remember we talked about in class how the average will be affected both by addition as well as multiplication and subtraction and division. Any linear transformation will be applied directly to the mean. So the mean of Y is just the mean of X after 32's been added and 9/5 has been multiplied. So I'm just taking my formula, and instead of the Celsius measurement, I'm putting the average of my Celsius measurements. So this would just be 32 plus 9/5 times the average in Celsius times 34 degrees. Because this is basically just saying, hey, what's 34 degrees in Fahrenheit? So when you do this, you'd find it's about 93.2 degrees Fahrenheit. Just because it's an average doesn't change this conversion formula into Fahrenheit. Standard deviation, though, does. Standard deviation is unaffected by adding and subtracting. It's a measure of width. Sliding left to right does not change your width. So that plus 32 is irrelevant. First, I'm going to think of my variance. So the variance of random variable Y will be that constant squared times the variance of random variable X. So 9/5 squared will be multiplied by my variance, which would be 4. That's supposed to be 12.96. So the standard deviation of Y is just the square root of this result. So remember, it's the square root of my variance that I just found. Square root of 12.96. So one of the key things to remember here, not only does the 32 not get added on, but you cannot just multiply by your 9/5. You have to take the square root of your variance times the squared constant being multiplied. So what this means is if we randomly select many days when the dial is set to baby safe, so if this process is repeated multiple times, the temperature of the bath typically varies about 3.6 degrees Fahrenheit from the average of 93.2 degrees Fahrenheit. I'll have that written out when I upload my notes in a second. There's no need for you to watch me write that down. I do want to finish filling out just this summary though. If Y is A plus BX, so there's some linear transformation where I added an A term and I multiplied by B. The probability of the distribution Y has the same shape as long as B is positive, which I'm only going to give you positive values here. The average, like I just did, you will add and multiply your original mean. Your variance, I should have had a blank on here for the variance of Y. This would be that constant squared times my squared standard deviation, so times my variance. And the my standard deviation, you know what, I think I just said you can't just multiply by B. You can just multiply by B is what I should have said. Because if I'm multiplying, I don't want to say this. If I would square root this to find my standard deviation, you are allowed to just square root each of those terms because it's a product underneath my radical. So I misspoke earlier. I could have found this 3.6 just by taking 9/5 of the old, it's already 3.6, 9/5 of the original standard deviation. So 9/5 times 2. Yep, I just wanted to confirm that. Technically, it's an absolute value because you theoretically could have a negative B value that you're multiplying by. I will give you only positive, so you don't need to fret about that. But I did want to talk about the variance being that term squared, and then the square root of that product.